Good evening, everyone, and welcome to today's lecture. In today's lecture, we will go ahead and complete, I think, your electric potential wala part. In the last class, we had discussed the potential due to various type of charge distributions. I hope you remember them. Yes or no? Okay. Now let me bring a simple question to you, the simplest of them all. Let us imagine that there is a conducting sphere. Let us say this is a conducting sphere of radius r, and the charge on this is plus q. And then you have a small charge minus q placed at a distance of x from this conducting sphere. We have to find the energy of this system. This is just one question that we have not discussed. So you have to find the energy of this system which has one sphere or one conducting sphere and one point charge. I'll give you 1 minute, 2 minutes to solve this question, and then we will move ahead. Yes, anyone with an answer? You have to find out the energy of the system. I told you how to find out the energy of 2-point charges. If you can remember that, you should be able to get me the answer of this one. I'm counting on you guys to give me the answer. Yes, bacha. What is the answer for this one? Yes, so anyone got the answer? No one? Well, the answer is very simple. How do you get the potential energy of charges? Because of this sphere, you can find out the potential at this point. Just find out the potential due to the sphere at this point and multiply it by the charge. What is the potential due to a sphere at any point outside? I told you yesterday, it is k q by the distance from the center. That distance is x. Kq by x is the potential created by this shell or sphere. Multiply it by the negative charge over there. So this is the answer, minus kq to small q by X. That is the potential energy of this system. Whenever someone says potential energy, you just find the potential and multiply it by the charge. Do we understand this? Yes or no? Okay, so that was the potential energy of this system. I'll give you 1 minute to note it down. Please note it down. If you have any problems, any doubt, beta, please ask. What I am feeling is that you're not paying attention to the class. I don't know why. If there's anything that you have not understood, please feel free to ask me. Anything. Have you understood this one? Yes or no? Okay. I will take your words. Boys are invisible. They are somewhere sitting somewhere which I don't see. I hope everything is fine. Yes? Okay. Okay. Great. Great. So please note this down so that we can move ahead. Noted it down. Shall we move ahead, boys?
Yes, sir.
Okay. Now, the next topic is relation between electric field and electric potential difference. So write the heading relation between electric field E vector and delta V. Delta V means the potential difference. So, I mean, this relation is basically an integral relation. So we can't do anything. We have to write it in that way. E is written as, if I write it not vectorly, let me write it scalarly. E can be written as minus dV by dr. It is the negative derivative of V with respect to R. In simple language, you can write this as like this, minus the change in potential divided by the distance. But that is not exactly very correct. The upar wala formula is the correct formula. The niche wala formula is just a tuta futa version of this original formula. Now, how are you going to use this? That is more important. So remember these few points and you will get a question based on these 2 points. Electric field or electric field lines, if you want to say. Electric field is always directed electric field or electric field lines is always directed from a point of higher potential to lower potential. Can you remember this? Electric field will always go from a point of higher potential to a point of lower potential. That is the first thing that you must remember. In the equation number 1, I have written electric field as a if you know the potential difference or you know the potential, you can find out electric field. The same equation can be written in the reverse form. The change in potential, delta V can be written as integral of minus E dot dr. You just have to remember these two relations because you are from the NEET thing. You may not be going to solve this integral, but you will have to remember this. Now it's a dot product, and therefore you will have to remember something. You can write it as E into dr into cos theta. E into dr into cos theta is the negative integral of E into dr into cos theta. And this cos theta relation is very important because most of the question that you are going to get can be solved using this cos theta factor. Do we understand this? Yes or no? Have you written this? So that means if theta is 0, then you can write your potential difference will be minus E into dr because cos of 0 is 1. Similarly, if your theta is 180 degrees, you can write change in potential will be cos of 180 is minus 1, so it will become integral of E into dr. Basically, when I am writing this, what I actually mean is if you go in the direction of electric field, your potential difference or change becomes negative. That means potential drops. Potential drops in the direction of electric field. So that is the meaning of this theta is equal to 0. Theta is equal to 0 or this negative sign means in the direction of electric field, potential drops. In the direction of electric field, in the direction of electric field, potential drops. Potential goes down, potential drops. Second case, when I say when theta is 180 degrees, change in potential is positive. That means I can say opposite to the direction of electric field, potential rises. Opposite to the direction of electric field, potential rises. Do we understand this? What we are saying here? Yes or no?
Yes, sir.
Okay. I'll show you a small diagram and that will make things more clear here probably. This is the diagram beta. You can see electric field lines of a positive charge going like this. You can see the point A and you can see the point B. Can you tell me with all the information that I have given you, which point will be at a higher potential, point A or point B? Which point is at the higher potential, point A or point B? Point A or point B? Which point is at a higher potential? Point A or point B? Boys, girls? Which point is at a higher potential? Point A or point B?
A, sir.
A is at a higher potential. Why A is at a higher potential?
It is opposite to electric potential.
Electric field lines are going from A to B. Please read what is written in the what we have written and what we have understood. I have written electric field lines always go from a point of higher potential to a point of lower potential. Here we can see electric field lines are going from A to B. So A should be at higher potential and B should be at lower potential. I also tried to make you understand this before, but it seems I can see that you are not paying attention these days. I had given this same concept to you before also, but I don't know why you are not paying attention. See, here electric field lines always go from a point of higher potential to lower potential. I had shown it to you. We had written everything, but now it seems like you have stopped paying attention for God knows what reason. Is there anything that you are not able to understand? Please ask, please tell me so that I can improve. Is there anything that is troubling you? Boys, girls? Is there anything that I can help you out with? Are you able to understand this? Maybe I am not getting it correctly. It can happen. Okay. So when theta is 0, you are moving in the direction of electric field. Potential will drop. The other way of saying this thing is electric field lines will always go from a point of higher potential to a point of lower potential. What happens if the angle is 90 degrees? What will happen if the angle is 90 degrees? So we can write that as a third point. If theta is 90 degrees, potential difference becomes 0. That means all points are at same potential. All points are at same potential. Or you can say moving perpendicular to electric field, potential does not change. Moving perpendicular to electric field, potential does not change. Do we understand this? If you are moving from a point perpendicular to electric field, then potential will not change. It will remain constant. Potential will remain same. Now, when potential remains same, that points will lie on something which we call equipotential surface. So that is the next heading, equipotential surface. Equipotential surface. What do you mean by equipotential surface? Equipotential surface consists of points having the same potential, the same electric potential, the points having same electric potential is, if you draw a surface which has points of the same potential, that surface will be known as an equipotential surface. Do we understand this? Now this equipotential surface your equipotential surface will be perpendicular to your electric field, because in a direction which is perpendicular to the electric field, potential does not change. So your equipotential surface will be perpendicular to your electric field. Suppose your electric field lines are going like this. Suppose your electric field lines are going parallel like this. Then if you move perpendicular to this line, that means if you move along this line, perpendicular, if you move from A to B, your potential will not change, and this becomes a equipotential surface. Do we understand this? Boys, are we there in the class? This
Yes, sir.
is your equipotential surface. If I draw one more parallel line like this, let me call this as CD. Your CD also would be an equipotential surface. Do we understand this? And similarly, I can draw more equipotential surface. Now, if you can tell me which surface would be at greater potential, which surface, you have got two surface AB and CD, which surface will be at a higher potential? I'll give you 2 minutes to draw it, think about it, and let me know the answer. Which surface do you think would be at a higher potential? Which surface do you think would be at a higher potential, my dear friends? Think about it. Tell me the answer. Which surface do you think is at a higher potential? I'll give you 2 minutes to think about it. Have you drawn the diagram, beta? Yes or no?
Yes, sir.
Okay, good. Now, can you tell me which potential, which surface will be at a higher potential and which surface would be at a lower potential? There are only two surfaces. Which surface would be at a higher potential and which surface would be at a lower potential? Yes? We have written this so many times.
AB.
Why AB? There must be a there must be. Abhiram also saying AB. Why AB? There must be a reason. AB will have higher potential. Yes, but why? There must be a reason. There must be a reason. Because it goes from higher to lower, says Abhiram. What goes from higher to lower, beta? What goes from higher? Electric field lines. That is correct. Now you have a correct answer. You can see here, my dear friends, electric field lines. Look at the direction of electric field lines. Look at the direction of electric field lines. Electric field lines are going from left to right. That means left surface will be at a higher potential and the right surface will be at the lower potential. Do we understand this, everyone?
Yes, sir.
Boys, can I have raise hands from you that we understand this?
Yes, sir.
Well done. AB is higher potential and CD is lower potential. Now, knowing the potential of AB and CD, my dear friends, we can do a lot more. Let us say, let me move on with the same question. Let me say that this is 10 volt electric equipotential surface. The potential is 10 volt and this is 5 volt. What is the potential difference between AB and CD? What is the potential difference between AB and CD? Tell me, anyone, what is the potential difference between AB and CD? Simple question I've asked, my dear friends. What is the potential difference between AB and CD? One is at a potential of 10 volt. The other one is at a potential of 5 volt. I'm asking you very simple thing, very simple concept, very simple question. What is the potential difference between A, B, and CD? And I'm having an answer. Yes, what is the answer?
5 volts. Sir.
Yes, 5 volt. 10 minus 5 is 5. So it is 10 minus 5 volt. The answer would be 5 volt. Do we understand this, everyone? Yes or no? No, yes, boys.
Yes,
Okay,
sir.
now let us take one more step. I know the potential difference between AB and CD. I will give you one more information. And what is that information? The perpendicular distance. Remember my words. The perpendicular distance. Remember my words. The perpendicular distance between AB and the CD is, let us say, 2 meters. The perpendicular distance between AB and CD is 2 meters. With this information, you can also tell me the value of this electric field. What is the value of the electric field? I'll give you 2 minutes to think about it. What is the value of this electric field? I'll give you 2 minutes to think about it. What is the value of this electric field? Just look at what we had done. I've given you something, 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 something. If you use that something, 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 you will end up with the answer dear. Something, 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 and you will end up with the
2.5,
answer.
sir.
Yes, now we are picking up some space. Yes, pace, sorry, not space. Yes. What is the value of electric field? Eh? Gave me an answer now, it is gone.
Minus 2.5. Wow.
Minus only indicates the direction. You already know the direction, so don't have to.
2.5, sir.
2.5. 2.5. You don't have to say direction. You can say the value in volt per meter because this is volt divided by meters. You don't have to say negative because negative only means the direction, and I'm not talking about the direction. So if you know the equipotential surface, my dear friends, from those equipotential surface and you know the perpendicular distance between the two equipotential surface, you should be able to find out what? You should be able to find out the value of electric field. Do we understand this? Yes or no?
Yes, sir.
Well done. Now things are looking a lot brighter. Have you understood the concept of equipotential surface? Electric field lines are always perpendicular to the equipotential surface. Okay. Now let me ask you one more question based on this. I am very excited. Let us solve. Let me draw this first. So let us say this is my something something, and then I have these lines drawn like this. They are drawn at an angle of 45 degrees. This, as you can see, is X. And what I have drawn here are equipotential surfaces. See? This equipotential surface is a 5-volt surface. Oops, wrong color. I hate wrong colors. This is a 5-volt surface. This is an 8-volt surface, and this is an 11-volt surface. And this distance is given as 2 meters between this point and this point. You have to tell me first thing, what would be the direction of electric field lines? What will be the direction of electric field here? That is the first thing that I'm asking, my dear friends. What is the direction of electric field? If you can first tell me that, then I will move ahead in life. Life has to move on, you must see. Life has to move on, but to move on, you must first tell me, can you tell me the direction of electric field from the information that I have given you?
Sir, left direction.
Sir, left direction. What do you mean by left direction? Left direction. So should I draw it like this? Dang 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 dang. Should I draw them like this? Left like this? No. Then dang 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 dang, they are going to get disappeared. Yes, then how should I draw them? Remember, your electric field line should be what? Perpendicular. So they must go like this. Dang 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 dang. They must go perpendicular. Do we understand this? Yes or no?
Yes, sir.
Sir,
Well done, sir. So this is dang 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 dang. They are going like this. Can you tell me the value of electric field? Just asking a simple question. Can you tell me the value of electric field? Nothing else. Nothing else I need. Nothing else we need. Just have to tell me the value of electric field. I'll give you 2 minutes. Proper 2 minutes. Anyone with anything that looks like an answer?
1.5, sir.
1.5, sir.
1.5, sir. How did you get it, sir? Aviram, what's your answer? 1.5. Students are getting 1.5 unanimously. 1.5, sir. Everybody getting 1.5. Congratulations. That is the wrong answer. 1.5 is not the right answer. Then what is the right answer? To know the right answer, you must go back in the past. This is the past. And I have a time machine, so I can take you back there in the past. In the past, that is what we did. Learn from your past. If you've done something correct, repeat it. If you've done something wrong, hey, avoid it. This is the past. Looking glorious. Yes. Yes. I'm still waiting for the answer. That was past. This is present. Where is the answer? Past, present, past, no, past, present, future. Where is the answer? Past, present, future. Where is the answer? Somewhere between past, present, and future. Somewhere in there. You have 1 minute to show your talents, else I'll show mine. 30 seconds. Countdown has begun. Root 2, which is given to you, is this distance, is root 2. This is not the perpendicular distance, my dear friend. You had to find out this distance, which is the perpendicular distance. This is 2. This angle is given as 45. This is a right angle triangle. Right angle triangle. Right angle triangle. If I draw this right angle triangle, it looks like this. Ding, 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 ding. This is 90 degrees. This is 2 and this is 45. If you see it in a nice way, you have to find out the length of this side. How much will be this? Your hypotenuse is 2 meters. You understand this? So this will be 2 cos 45. So this will be 2 divided by root 2. So it will be root 2. This length would be root 2. Do we understand this?
Yes, sir.
Now what is your answer? Your value of electric field becomes delta V divided by delta R. Your difference in potential is 3 volt divided by root 2 volt per meter. Do we understand this?
Yes, sir.
Now both the questions look same, they feel same. Remember, whenever you have to find out electric field from potential difference, you will have to use which formula, which distance. You have to use the perpendicular distance. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay. Can we move ahead? Everyone understands this? Shall we move ahead, bacha?
Yes,
Yes,
sir.
sir.
Okay. Now here what we have done is we knew the equipotential surface, and from there we try to calculate the value of electric field. Yes or no? No, yes. In the second case, what we are going to do, we are going to do the opposite of it. What do you mean by opposite of it? We will know the value of electric field and we will calculate the potential difference. Can you do it? We have done the reverse. Can we do it in the correct order as well? Yes or no? So how are we going to do it in the correct order? Next question. We have this ding, 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 ding. What is it? Ding, 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 ding. What is it? Ding, 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 ding.
Electric field lines.
Electric field lines. The value of this electric field lines is 2 volt per meter. Then I have two revolutionary points. One is point A here, the other is point B here. Same straight line. The distance between these 2 points is, let us say, 5 meters. The first question that I am going to ask, my dear friends, is which point is at a higher potential? Which point is at a higher potential? Which?
A, sir.
Everyone understands? A. A is at higher potential, yes or no?
Yes, sir.
Now, can you tell me what is the potential difference between A and B? What is the potential difference between A and B? Abhiram has already come up with an answer. Potential difference between A and B. A is at a higher potential. What is the potential difference between A and B? So how do you find out the potential difference? Remember, we had this formula, electric field is minus delta V by delta R. You can write that in a different way. Delta V is E into delta R. Not an exact formula, but yeah, in your case, it will do the job. Minus sign only indicates which point is higher and which point is lower. Yes. What is the potential difference between A and B? And the answer is
10.
10, sir.
everyone got this? 10, sir?
Yes, sir.
10 volts. Can I have raise hand from everyone? Okay, I have a point C here. The distance between this point A and this point C is 10 meters. Can you now tell me the potential difference between A and C? I'll give you 1 minute. What is the potential difference between A and C? And the answer is anyone with an answer? Potential difference between A and C. 20 volts, sir. Comes an answer from Abhinav. What about other students? 20 volts? Yes or no? Answer is 0. Why it is 0? Because when you go from A to C or C to A, you are always moving how?
Same.
You're always moving perpendicular to the electric field, my dear friend. And this A and C will become an equipotential surface. An equipotential surface, the potential will remain same as 5 or whatever the answer is, whatever the value is. Do we understand this? When you move perpendicular to a electric field, potential does not change. Do we understand this? Yes or no?
Yes, sir.
Do we understand this? Yes or no?
Yes, sir.
Okay. Now, if someone asks you, what is the potential difference between C and B? What is the potential difference between C and B? So what do? You will have to move from C to B. You will have to move from C to B. Now you can move from C to B in different ways. You can move from C to B in this direction like this. You can move from C to B in this direction ऐसे ऐसे करके. Or you can move from C to B first like this and then like this. Remember, potential difference between 2 points does not depend on path, and that is one important point that you must remember. Potential difference between 2 points. Potential difference between 2 points does not depend on path. does not depend on path. So if I go in the green path, or if I go in the yellow path, or if I go in the blue path, the potential difference will remain same. So if I have to find out the potential difference between C and B, the easiest way is I move perpendicular first. I go from A to C, and then I go from C to A, then I go from A to B. When I go from C to A, there is no change in potential. When I go from A to B, so I can write it like this: VC minus VB will be VC minus VA plus VA minus VB. Do we understand how I've written this? Minus VA and plus VA. Yes or no?
Yes, sir.
So this VC minus VB also becomes 10 volts. Remember, the potential difference between 2 points does not depend on path. We will do more questions on potential difference, one or two more questions from your previous year paper as well, and see how this question come. But what you got to remember is potential difference between 2 points does not depend on path. And we will choose the easiest part to go there. We'll continue with this class, with this discussion in the next class. Take care. God bless you all. If
Thank
there's
you, sir.
anything that you have not understood, beta, any doubt, please let me know.